Hello, folks. In this lecture, we are going to look at one of the most commonly used parts of combinatorics, permutations. Permutations represents the number of different possible ways we can arrange a set of elements. These elements can be digits, letters, objects, or even people. To clear any confusion, let's look at an example. Imagine you haven't watched the latest Formula One race, but your friend spoiled who the three drivers on the podium are: Lewis, Max, and Kimi. A permutation of 3, denoted P of 3, would express the total number of different ways these drivers could split the medals among one another. Suppose Lewis won the race. Then we have two possible scenarios. Max finished second, and Kimi finished third. Or Kimi finished second, and Max finished third. Now, suppose that Max won. Once again, we have two possible outcomes, but this time, it is Lewis and Kimi who have to split the silver and bronze medals. Either Kimi got silver and Lewis got bronze, or the other way around. Not surprisingly, if Kimi won the race, we would have two more ways the drivers can be arranged on the podium. Either Max gets silver and Lewis gets bronze, or Lewis gets silver and Max gets bronze. In total, this leaves us with 6 unique ways these three drivers can split the top 3 spots. We call these 6 ways permutations, and we're going to show you how to compute the number of permutations for a finite set of any size and in different situations. Great! Now let's discuss the intuition behind computing the total number of permutations for a set of n many elements. We start filling out the positions one by one. The order in which we fill them out is completely up to us. For convenience, we usually start with the first slot, which represents the race winner in our example. Since anybody out of the n many drivers in the set could have won the race, we have n different possible winners. After that, we have n minus 1 possible drivers left, and any one of those can finish second. Regardless of which out of the n elements we chose to take the first slot, we have n minus 1 many possibilities for the second slot. Similarly, we would have n minus 2 possible outcomes for who finishes third, and so on. Generally, the further down the ranking we go, the more options we exhaust. And the more options we exhaust, the fewer options we have left. This trend will continue until we get to the last element, for which we will only have a single option available. Therefore, mathematically, the number of permutations would equal the product of n minus 1, n minus 2, and so on until 1. We denote this product as n factorial, and in the next video, we're going to discuss some of its main properties and how these properties relate to permutations. See you there, and thanks for watching.